All right, number 43. We just talked about this on 42 when we are squaring binomials. So we know that when we see a squared right here, we are actually going to write our binomial 3x minus 5 times itself, another 3x minus 5. Now we can distribute or multiply with a box. I'm just going to go ahead and distribute this one. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Now let's distribute this negative 5 times 3x is another negative 15x. And negative 5 times negative 5 is a positive 25. All right, combining like terms, we have our 9x squared. Those negative 15x's will combine to negative 30x and plus 25. Did we just do this problem, number 42? Maybe with a different variable? Seems very familiar. That's all right. We don't mind more practice. All right, 43b. Again, we are squaring a binomial. So you have to write it twice and multiply it out. So we're going to have 4x plus 2 times another 4x plus 2. All right. Again, if you like to multiply with a box, go for it. I am just going to distribute this. Sometimes I like distributing. It feels like it takes up less space. It's also what I grew up doing, but the box method is a great visual for multiplying binomials. 4x times 4x is 16x squared. Remember, we add our exponents with multiplication. 4x times 2 is a positive 8x. 2 times 4x is a positive 8x. And 2 times 2 is a positive 4. All right, final answer, we'll combine like terms. That x squared, 16x squared, has no like terms. We've got the 8x and 8x, those add up to a 16x. And then that plus 4, the constant term on the end, stays. All right, number 44, find the product. All right, so one thing I do just want to point out here, see how this looks a lot like just squaring a binomial, but these two binomials are not exactly the same. One has a subtracting a 4 and one has an adding a 4. So let's just see what happens when we multiply that out. Again, multiply with a box if you prefer. I'm going to multiply with distributing. 8p times 8p is 64p squared. 8p times a positive 4 is a positive 32p. Now I'm going to distribute the negative 4. Negative 4 times 8p is a negative 32p. And negative 4 times 4 is a negative 16. All right, when we go to combine our like terms, we've got the 64p squared that has no like terms. But now we have a positive 32p and a negative 32p. These are opposites. Opposites will add up to 0. So those are going to add up to 0, leaving us with that constant term of minus 16. And here's our final answer. So when we cross these off, just be careful you don't accidentally do that. If they have the same sign, they're not opposites. They won't add up to 0. They actually add up to some value. But when they are opposites, that's when you see us crossing things off and it equals 0. All right, number 45, find the product. All right, so this is just taking a monomial multiplied by a trinomial. So this looks like a pretty typical distributing problem. So let's just distribute. We've got, if you did do a box, it would be a 1 by 3 box, if you prefer that. No problem at all. All right, 8p times negative 3p squared. So 8 times negative 3 is negative 24. P times p squared, add your exponents to get a p to the third power. Now let's distribute. 8p times a positive p is a positive 8. P times p is p squared. And then 8p times a negative 2 is a negative 16p. Does our final answer have any like terms? It does not, so there we go. All right, part B, very similar. We're going to go ahead and distribute the 2n. If you want to multiply with a box, it'll be a 1 by 3 box. Let's see, 2n times n cubed, n squared, my brain went to the cubed, is 2n, add your exponents to get the n cubed. Now 2n times 3n, 2 times 3 is a positive 6, n times n is n squared. And then 2n times 4, 2 times 4 is a positive 8n. Any like terms? Nope. There we go. All right, 46. Factoring. All right, factoring is look for a GCF first and then see if there's any factoring you can do after that. So, do these two terms have any common factors? So 25 and 35. Yeah, you could factor a 5 out of those. So let's think about what our GCF would be. So GCF will have a 5. Do they have any common variables? W to the 6th, W to the 3rd. Yep, they've both got W's. What's the most W's they both have? W to the 3rd. So we're going to factor out of 5W cubed. And that's going to go out in front, and we're going to factor that out of each term. So 25W to the 6th, we factor out of 5W to the 3rd. So factoring is division. What's 25 divided by 5? That leaves us with 5. But if we have W to the 6th and we factor out W to the 3rd, leaves us with W to the 3rd. I'm going to carry down the plus sign. 35 factor out or divide out of 5 leaves us with 7. And then W to the 3rd, we factor out a W cubed, and there are no W's left with the 7. So I'm going to close the parentheses. Quick check. Inside the parentheses, do these two terms have anything in common? They do not, which means we did a good job finding that GCF. Can we continue factoring a 5W cubed plus 7? So if you're asked to factor a binomial, two terms, this will only factor if there is a GCF, which we already factored out the GCF. These don't have anything in common. Or if this was a difference of two perfect squares. Well, this plus sign right here is a sum, not a difference. So we actually can't do any more factoring with this. So this one's done. All right, part B. What are we going to look for first? GCF. So 2x cubed plus 4x squared plus 8x. All right, you guys already know they have a 2 in common. And then any x's? Yes, a 2x. So we're going to factor a 2x out of every term. Our factored answer, that 2x is one of our factors, so let's make sure we include that. 2x cubed, factor out of 2x leaves us with an x squared. 4x squared, factor out of 2x, so 4 divided by 2 is a 2, so I'm going to carry down the plus 2. If we have an x squared and we factor out an x, we do have an x left. And then 8x, factor out of 2x, so 8 divided by 2 is plus 4, and then that 4 will not have any x's left. So let's do a quick check. Inside parentheses, do these have anything in common? Nope, nothing in common, so we feel good about our GCF of 2x. But now let's think if we could keep factoring. So inside the parentheses, we have an x squared trinomial. And it's just an x squared. There's not a number in front of the x squared, so you wouldn't have to factor with a box. So we can jump right to our c value. Do we have factors of 4 that add up to our b value of 2? So let's think about that for a second. Factors of 4 are 1 and 4 and 2 and 2. Do any of those factor pairs add up to a positive 2? And you would say, no, Mrs. Youngberg, they do not. And I would say, you know what? You're right, super smart students. We cannot factor that any further, so this will be our final factored answer. But we want to consider it because sometimes we can keep factoring. And if you can, you keep going. If not, then we say, we're good. We got it all. Okay. Number 47, write the system of inequalities represented by the graph. Okay, so I see two lines. One has a solid line, one is a dotted line. What we're going to do is we're going to write the equations for both lines, identify slopes and y-intercepts, and then based on where the shading is, we will have, instead of y equals, we'll have inequalities. So is y greater than or is y less than? But why don't we start by identifying the slopes and the y-intercepts? So I'm going to see if I can just, there we go. That's what I want. Zoom in a little bit, right? Let's make this so you can see it. All right, I'm going to work with this line first, this blue line. So it's easy for me to spot the y-intercept. I can see it's crossing the y-axis at 3. So the y-intercept is at 0, 3. Now the slope, if I follow along this line and try to find another exact point, I think that looks like a good point right there. So I'm just going to put a point there as a marker. And now I'm going to count the rise over the run. So we always start with a point on the left. I'm going to rise and then run. So how many did we rise? Let's do a quick check of our axes. We are counting by ones on the axes, even though they only wrote every other number, it is counting by ones. So our rise is a positive 2, and then we ran a positive 3. So rise over run, our slope is 2/3. So we have our mx, our mx plus b. We've got those numbers. Now, because this is a solid line, we're going to have either a greater than or equal to or less than or equal to inequality. The ones that have the or equal to are your straight or your lines. All these are straight, but your solid lines. And then we just have to think about where the shading is. So if I look at this solid line, did we shade above or below this? Over on this part of your graph is where that's going to be a little bit more obvious. So here's the line. See how we have shading here, but not here? So what do you guys think? Would you say this is above the line or below the line? And I am a fan of like drawing arrows to the shaded region. Because I'm drawing an arrow down, I know that that's going to be below the line. Anytime we shade below, we use a less than. So we're going to use this inequality. All right, so we can write one of our inequalities. We've got y is less than or equal to. Now we just need the mx plus b. We set our slope, the m was 2/3, so 2/3 x. And then the b is the y-intercept, positive 3, so plus 3. All right, so we've got half of our system done. Now we're going to identify the same information for the red line. All right, so I'm going to zoom in. Now let's focus on this red line right here and get all the information. So starting with a y-intercept. So y-intercept I can see is right here at -1. So the y-intercept is 0, -1. And now we want to try to find the slope. So I am going to follow along the line till I feel like we have a nice exact spot. I don't feel like we get one till like right here. So I'm going to plot a point here as a marker, right here. And now let's count the rise over the run. Do you guys notice how this is a downhill line? That means that we will have a negative slope. We want to make sure we don't end up with a positive slope by accident. We always start with the point on the left. So we're going to do the rise first. We are rising down. So we're going down, and then we're running to the right. Remember, we always run to the right. So we're going down. Let's count the units. 1, 2, 3, 4. So -4 because we went down. And we're running 1, 2, 3, 4, 5. 5 units. So our slope is -4/5, rise over run. All right, now because this is a dotted line, that means we're going to choose between the inequalities of greater than or less than. So let's figure out, did we shade above or below this line? I think when we come over to this part of the graph, it's a little bit more clear. Here's this dotted line we're working with. See how the shading is up here and not in this section. So if I go to the line I can draw straight up or straight down. Which one is going to get me into the shaded region? It is the straight up. So anytime that you guys shade up, that is a greater than. So now I'm going to come back over here where we started writing our system, and I'm just going to write this inequality right below it. We've got y, oops, need my marker. We've got y is greater than, we said our slope was negative 4/5, x, and our y-intercept is a negative 1. I'm going to put one of these fancy little brackets, and here is our system of inequalities.